Hi, good day. I'm Neil Carpenter with Orca Security. I'm our field CTO. Orca is a cloud-native application protection platform focused on securing and giving you visibility into all of your everything running in the cloud, whether that's AWS, Google, Azure, Oracle, Alibaba, etc. So today we're going to talk about, we recently announced an integration with Snyk that enables security teams to really have visibility into what developers are doing, developers to have visibility into what's happening uh, with their deployed code. And so I think it's a really exciting opportunity. But I want to start out with, and this is pretty obvious, application security is not easy. This is something I spend a dramatic amount of my time talking with customers and people in the industry about. But we see a number of problems here. And this is all friction, right? So developers really lack context often. Um, if we go way back, security teams tended to send developers a spreadsheet of CVEs that they had to fix with no information about what those CVEs are, why they had to be fixed, et cetera. And this has become a point of contention over the years. And so even today, we commonly see developers who are pushing back on why they have to fix something, what has to be fixed. It lacks the context to explain why a particular vulnerability is critical to be fixed and another one is not. And so we see so often friction around this. We see developers pushing back. We see a lot of back and forth in security teams and a lot of unnecessary effort involved in getting security updates patched and delivered. So we want to start there and really enable developers to understand where problems are and what that context looks like. On the other side of that, security teams aren't developers. And once again, I'm saying obvious things, but this is a huge point of contention as we move into the cloud, as we move into cloud native computing, and we look at how we address vulnerabilities. I often say before we moved into the cloud, when we were on-prem, if we had a couple of VMs that had, let's say, a critical Tomcat vulnerability that allowed for remote code execution, somebody in security would create a ServiceNow ticket. Somebody in ops would come along at 3 a.m., patch those VMs, reboot them if they need to be rebooted, close the ticket, everything's done. And that's something that security teams readily understand. They get it. As we move into the cloud and as we move into cloud native delivery of applications, the entire calculus changes. If I've got 20 containers running on top of Kubernetes running in the cloud, I can't go patch those running containers. I guess technically I could, but it wouldn't be very effective. The next time that it scaled up or down, we would get new containers based on the existing image, and so the vulnerabilities would come right back. It's not an appropriate solution. The appropriate solution is from the security side, we have to go find the developer, create a ticket, indicate to the developer what needs to be done, and then the developer has to change their code, rebuild the container image, retest the container image, reship the container, and then redeploy the containers that are running based on it. So it's a completely different approach for security teams. It's been very difficult to really get their arms around and understand and operationalize and build the right processes, get the right visibility, um, and have a shared language and a shared view of what's going on. And then the third point here, prioritization is incredibly painful. Um, this is when I talk about prioritizing vulnerabilities. So often the security teams have traditionally just looked at the CVSS score. That is, how critical is this vulnerability? Is it CVSS 3 and it's low criticality or low severity? It doesn't matter. Is it CVSS 9.8? It's very severe. It allows for remote code execution. That is, I think we all realize today, not the best approach. Um, or it's part of a good approach, but it's not a full approach. We have to look at not just how severe is the vulnerability itself, but a lot of information about how exploitable is it, both in our code itself. Is it something that's actually used? Is it not used by our application and it just happens to be there for no apparent reason? Is it something that's accessible? So is it something that is in fact, it's running in a web application exposed on TCP/80, and in fact TCP/80 is open to that container where it's running? Is it accessible? And then finally, what's the bigger context? Is it deployed and running? Is there sensitive data there? Is there all of this other information that would tell us that this instance, this cluster running, this deployment is important? This one over here is pre-prod. There's no interesting data. It's not that important. That combination of factors helps us prioritize, but we've got to have eyes on them and we've got to be able to consume them and get that data in front of the right people making the right decisions. So all of that leads me into and this is a bi-directional integration, but Snyk's integration with Orca, Orca's integration with Snyk. So first of all, I come from a security background. I am not a developer by nature. So let's start with the security side of this. From an Orca perspective, Orca is showing me across everything I have deployed and running in the cloud. First of all, what's my inventory? What do I have out there? What's running? Where is it? How's it configured? What's going on with it? But second, what are my risks? Where have I actually got problems in what's deployed and running? And so vulnerability management is it's probably the number one thing that our customers are doing, that our security teams who are running Orca are worried about across everybody I talk to. And so, they're so often looking at a new vulnerability that's shown up in a running container. It's critical. It's in the news. We're concerned about it. It allows for remote code execution. There's sensitive data. They have all of this telemetry, but they have no visibility into what's happening on the development side and how things are running in the development world. And so the first thing that this is doing is pulling in all of my Snyk scans that are going on. So I can see at a glance not only what the current state of this thing is. In this case, we're going to look at a container. What's the current state of that container that's running? But also, what did the developer see? What did the Snyk scan look like? What information do I have there so that I can include that into my analysis on the security side and understand that this was something that was good when it shipped. We were in a good state. Everything was okay. Or maybe we shipped it with some problems, and that's something we need to go back and address. So a very important piece of it, and we're going to dive into that. Additionally, this really enables us to go completely full circle, to come from development into the cloud and then to tie it back to who was the developer, who worked on this, what's the team that owns this, where do we need to go to get it addressed, to short circuit that process I talked about earlier of having to go back to the original developer and not just go patch a bunch of running things. And so that's enough slides for right now. Let's dive in and look at both Orca and what the Snyk integration looks like. And so here, I cut out a little bit of the work already. I'm looking at a particular container that's running on a web production machine in my Acme production cloud environment. So this is something for any number of reasons we can tell is running in prod. First of all, because the name prod is in the cloud account in the server itself. We can see this is a Tomcat container that's running some stuff. And so I can get a general view of this. I've got some alerts on the asset. It is running. It's running Debian 9.9. It happens to be out of support already. That's a problem I may be worried about. I can look at the software inventory here for what's running. I can see it's running Tomcat, SQLite, OpenJDK. I can dig deeper into all of the data about what's running on here. I shouldn't do that. I'm talking and moving my hands at the same time and hitting things. But I can dive into things like the software inventory. I can go look at risk, which is something that security professionals would typically be doing. So not terrible from a risk perspective. I've got a couple of alerts here. So for example, I can see that this is neglected because the host OS for the container that it's based on is unsupported. That's something I would probably want to take care of. I can look at the full alert for that and get all the details about, It's running Debian 9.9. That's been out of support since July of 2022. By the way, this is a demo environment that we maintain so I can show you things that are wrong. Hopefully your real production environment looks nothing like this. But as an example, there's a risk I might see. I might see that there are some vulnerabilities that we might be concerned about here. So there's two Java utilities that have, or I'm sorry, Java jars that have issues in them. I can look at sort of across all of, and there's some low severity vulnerabilities. So I can see all of these things here. I could look for things like, is there any sensitive information? Thankfully, this has no personally identifiable information, no secrets. Good work for the developer here. I can go look across all sorts of things. I can look at the underlying exposure. I can look at, this apparently isn't running as a role. I can look to see if there are compliance benchmarks that we're working with that may apply. So I get all of this view. Now, foundationally, once again, my problem as a security person is I see some issues here, like this is running an outdated version of Debian. That may be something we're trying to clean up. That may be deeply problematic. So what was our state at the point that we actually deployed this, or at the point we scanned it in Snyk? We can see here we are using Snyk. We've got the whole, we can see what GitHub repository it's in, where the Docker file that built this image is, Snyk, and we can see that in fact Snyk had critical vulnerabilities and high severity vulnerabilities or issues in it. And in fact, if I had access, and I happen to have access, I could go straight to Snyk and see that same data, and so I could see where my issues are. Snyk's telling me the same thing that Orca is telling me, so I know that the developers knew that in fact they're running an out of support operating system here. So now, from a security perspective, I have the full story of where is this, and what do I need to do, or what was the state? What did the developers see? How did they relate to this? And so that leads me back to here, and the next thing that I can do is I may need to figure out who to go talk to address this. Now, Snyk may help me with that, but also this is tied not just into Snyk and into my cloud accounts. It's also tied into, in this case, GitHub. This is stored in GitHub, and so I can get all of the underlying information there as well, not just the Snyk scan and the information there, when it was last scanned, when it was first scanned, how critical the issues are, but also what repository it's in. And importantly for me, who has done the work on it? And so I can see, the last commit. Now, oddly, the last commit on this one is from GitHub, but I can see who the code owner is. It's our DevOps team. I could see who's made the last commits to, or the recent commits to it. So Noah and Lior are the two people I would want to go talk to. Now I've got good visibility into it. And by the way, I can see the whole graph of here's the code repository, the Docker file, here's the container, the underlying, sort of all the pieces here if I need to go dig into any piece of this. So now from a security standpoint, I've got a complete view of all of everything that happened, what my developers saw, what the state of this was, what they knew were problems. And I can compare that with where I am now with what's deployed and running, and I can get back to who I need to get to fix something. So that's fantastic. And now I guess we'll go back to slides for the rest of this. You may be asking yourself, hey, Neil, you've talked about all the security people, but what about developers? And I'm glad you asked. I hope you were asking. I'm going to pretend you were asking, but that's the other side of it. And so the other, on the Snyk side, we're taking what Orca knows about all of these deployed assets, about these running containers, what we call observations, and we're pulling them back into Snyk. So now in the app risk functionality in Snyk, as you're looking at things and trying to prioritize and trying to understand the scenario, you can see for a running, or for a for a project in Snyk, what's the actual state of it? What's it doing? And so what I mean by that is you can look at all these containers that are out there, and you can see which ones are actually deployed and running, first of all. So you don't have to say, hey, this has got critical issues, but it's not running. Why do we care? More than that, you get other telemetry, like is it actually publicly accessible? Which is the sort of thing that if you're prioritizing what to work on and where to go, that's incredibly important. Something that's publicly accessible is typically going to be easier to compromise, more concerning than something that's not. So we're taking all of Orca's rich context, boiling it down to what development teams need to know, and pulling that back into Snyk where they're already working. So they're getting critical info without additional effort, without having to do anything else. So that's a quick look at Snyk and Orca combined, pulled together, integrated. If you want to learn more, we'd love to show you Orca, the whole platform, and the integration. You can use the QR code here to reach us.